Hello? Okay, again, let me start this over again. I need y'all, shut up and pay attention. There we go. All right. Now, I really need you people to pay super attention to this. If you have the notes out like I asked.
I don't have the notes. Oh, wait. I got two.
If you have the notes out like I asked, you're going to have to, listen please, you're going to have to write down these steps. Okay. Now, because our calculator is slightly different than the notes way that it goes over the calculator, I need you guys actually following along for this, because if you try and fall asleep, I will get super salty with you. You will take out your earbuds and you will put those away. And I don't care if you're trying to sleep in my class. Put the earbuds away. Kashad, please, earbud away. Thank you. Please, thank you. Okay, so on this one right here, polar form. Yesterday, we did what form? Rectangular. So today we're doing?
Triangular.
Polar. Okay, difference. Not really much, but now it actually goes around the circles. Or it goes around in the axes. So horizontal axis is the real. So the x is my real, the y is imaginary. So whenever we're doing points, it's going to look like this. I don't have a parentheses. I have a x direction and then a y direction. Positive 2 means to the right. Minus 3i means imaginary. It's going down 3. Okay? Super easy.
So add I to the right.
No. There'll be an I there. If there's no I, then what's my number?
0.
0. If there's no I, it's a 0 in that direction. Okay? All right, so some of these two. This is actually called the, there's two different things that you can do with this. So now, remember that conversation we had, and I said, all right, we're going in two different directions. You're taking your dogs for a walk. We have a Chiweenie and a Chow Chow or something. Anyway, so this is basically talking about two different vectors. Okay, two different directions. But in this, I'm actually got one going this way, one going this way, and then when we add them together, it's the same as what we did on the last set of notes. Add the reals, add the imaginaries. So 4 and 1 gives me 5, right? Yeah. Gives me 5. 1i, 3i is
4i.
There we go. We're just adding.
I'm good at math. Wait, is it squared or
no? It's just adding. Just add them together. That's it. So that's what it does when I'm putting this going this way, this going this way. You're going to somehow come out in between somewhere. Questions?
If you have a question, you
Speak.
No?
Super easy.
Is that it?
Oh, it is.
Oh, hey, it's gonna stay easy all day. Find the sum, then graph. Find the sum, then graph. Bleh. All right, find the sum, then graph. So let's do what I just did. What do I get there?
2.
Positive 2. What do I get here?
-5.
All right, so what does that tell me?
You're going in negative direction.
2 to the right and
5 down.
5 down. 2 to the right and 5 down. 2, 3, 4, 5 right here. There we go. I'm telling you, this is super easy. Probably at the last example, but I'd show you guys a way to not make it hard. Make sense?
Does it require a lot of steps?
Nope. Okay, R is going to be the radius. So we did Pythagorean theorem. Hey, look, is this like stuff that we've been doing all year long?
Yes.
Yes. So R would be the radius, right? So my Pythagorean theorem is x squared plus y squared equals r squared, right? And the distance from here to here is going to be the square root. So r square root of x squared plus y squared. And the y is my imaginary direction. So you don't put the I in there. You just want the number. The I just signifies that it is going in the imaginary direction now. Does that make sense?
Yeah.
That's super. All right. Okay. So expression r cosine theta plus I sine theta, trigonometry form or polar form of this complex number. Complex number here. Polar form is like this. The expression cosine theta plus I sine theta, sometimes abbreviated cosine I sine of theta. Cosine I sine theta, and when in the notation where I have the radius, I know the radius, it's r times cosine I sine theta. Okay?
So you said when we do the probably be r times.
Yeah, r parentheses, kind of like we have here. R parentheses cosine I sine. All right, express this in the rectangular form.
Nani?
Okay. I know, I forgot to clean when I was cleaning up my thing. I don't know. That's some part of the answer, I guess. All right. Okay, so let's take a look. My r is what?
600.
2. What is theta?
600 degrees.
300.
300.
You're adopted.
Okay, so now what is cosine at 300?
That's why he's here.
What is cosine at 300?
1/2.
1/2?
Said one, that's
Plus I. What is sine at 300? I heard it.
that's a long way.
Yeah, right?
Yeah.
Are we there?
No.
Did I lose anyone?
Wait, so it's just a.
I just put these points from 300 on my unit circle, right? The cosine at 300 was 1/2. The sine at 300 is negative right 3 over 2. Yes?
So do you put that in the calculator?
Not yet. If you put in the calculator, you're going to get all decimals. I don't want those yet.
No,
Yeah,
like
it's
cosine
confusing.
300.
Yeah, you can, but we're not doing all that yet. I'll show you guys when it's time to that. Because we're trying to turn this into rectangular form. Rectangular form is this right here. Trigonomic polar complex number right here. Well, we want it like this.
Ah.
We want it like that.
I know, but I'm saying like, how'd you get 1/2?
Oh, unit circle.
Okay, okay.
Unit circle, 300 degrees. The cosine is 1/2. All right, go ahead, do my distribution. 2 times 1/2 is 1. Okay, plus a negative. It's minus, right?
Yeah.
So it's minus. Now 2 times this over here, what do we get?
Red 3.
We're at 3.
Ah. That's simple.
And what am I missing?
Clean.
I. So I'm gonna put the I. You could, like I said, you could put it in front or you can put it in the back, but I highly recommend the front.
Does it matter?
No, but as you're putting it in the calculator, if you do not arrow over when you're actually putting the I, there's a difference in between rad 3
It'll become part
I
of the
and
rad.
rad 3 I.
It'll become part of the rat.
Okay? So if you put it and you're not careful about that, if you put it over here, you on this side you don't have to worry about it. Over here, you got to be careful to make sure it doesn't end up in there. Okay? All right. Super easy, right? Sketch a graph of the number x plus yi in the complex plane. Find r by using the equation. Find theta by using this inverse tangent. choosing the quadrant in step 1. All right. I even told you what it was. How do we find theta? Whenever we're trying to find the angle, we use the inverse. Whenever you're trying to find the angle, you use the inverse. So what am I going to write down right here, right now? Inverse. So it's theta equals inverse tangent of y over x.
Step up to the game.
So that's important because that's going to be your steps to find theta. Okay, correct quadrant. All right, let's take a look. So I'm going to first sketch it in this way. So it says negative rad 3 plus I. Okay, how much do I go in the I direction?
0.
1. Positive 1I, right?
Yeah.
Okay, so negative rad 3 is about right about here and right here. So it's going to look something like that. Something like that. All right. Now, on this one, it says use radian measure, too. All right, okay. Sketch graph in the complex plane. Dang. All right. Write it in trigonomic form. So what is trigonomic form then? What is trigonomic form? Sine, cosine, right? Okay, let's do both. All right, you guys ready? Okay, so let's go ahead and find the r. So r is equal to the square root of a squared. So what is it? Negative rad 3 squared plus I squared. But what I said not to put the I. What do I put? Just 1, right? Just 1. I want the number in front, which is a 1. I just says it's going to go in the up and down direction. 1 squared. So that's going to be 3 plus 1 is 4. Square root of 4 is? R is 2. All right, how do we find theta?
Inverse.
Inverse tan? What is it? Y over x, right? What's my y? 1, right? 1 because this is the y direction, right? So it's 1 over negative rad 3. Nope. You don't have to rationalize. Put it in a calculator. It says use radian measure, but I don't want to do that. I just want to convert my answer when I'm done. Because that's going to make it a whole lot easier. Let's see. Arctangent. There you go. All right. So arctangent of 1 over negative rad 3. So it's negative 30 degrees. Okay, so now let's convert that to, convert it. So let's see. How do we convert it?
Calculator.
We want radian, don't we? I would do what? Multiply by pi over 180, right? Multiply by pi over 180, which I get negative pi over 6. But is that in the right spot? Say no.
No.
It's not in the right spot. Where's it at? Is it over here? It's right there, isn't it? Okay, so that's negative pi over 6 or negative 30 degrees, right? What would I do to put it in the correct coordinate? Add pi. I'm going to add pi because I'm down here. I want it to be over here, don't I? I want it to be over there. So if it's going to be over here, I need to add pi. So it's going in the opposite direction. It's complete other side. So I will add pi. So if I'm adding, so I have negative pi over 6 plus pi. Right? Isn't that 6 over 6 pi? Where we get my theta, 5 pi over 6. Okay, I'm going to give you guys your first break after we're done with this problem. Alright, we're almost there. I have to have my thing in CIS. So how would I write my answer? I'll do blue here. How would I write my answer? What's the R? 2. CIS. And what is my angle?
30 degrees.
No. 5 pi over 6. Remember, in red is where it's at, right? Say yes. In red it's where it's at, but since it's right here, and we know that's where it's supposed to be at, but when I did it in the calculator, it came out over here. This is negative 30 over here, isn't it? And to get it to where it's supposed to be, I had to add pi. Because of where this ends up at, I added pi, so my new angle has to be 5 pi over 6. Questions? Is everyone just dead?
Yeah.
Too much kickball?
Where does CIS
Or dodgeball? Huh?
come from?
CIS? Oh, from the previous. It is, hold on. There you go, right here, CIS. CIS stands for cosine I sine. So it's R, which is my radius, times cosine theta plus I sine theta. So it can be written as this, or all the way out. I like CIS, because I like abbreviating. I don't want to write out that whole thing. Do you want to write out that whole thing? You do? No, right?
And it's without theta, right?
And theta, right? And so they both have the same theta. That's why I'm leaving it like that. So since they both have the same theta, it just combines to this. Make sense? All right. So I'm gonna pause it up here and give you guys time. I want you guys to start some of the practice. We're gonna finish these. All right. So continuing the notes after our break. All right. So those other people that did not make it back, you know what? I gave them 5 minutes, didn't I? Yeah. So anyway. All right, so we're going back to right here. All right, so write this. We're going to write this one in trigonometric form using degree measure. So if it is going to be just this, that means what is it in the real direction? 0. 0 minus 3i. Yes? 0 minus 3i, so that means it's just going straight down 3. Yes? Let's do Pythagorean theorem. So r is equal to the square root of 0 squared plus negative 3 squared. So what are we going to get for my r? Positive 3. R is equal to 3. Is that all that you could find? Ashley? You only could. Okay, so R is 3. Now, we're going to go through and actually figure out my values now. We're going to figure out my values. So now from here, I need to find my theta. Shh. I need to figure out my theta. Theta equals arctangent of, so it's 3 over 0. It's negative 3 over 0. What do we get? Undefined, right?
So no.
That one's going to be undefined. Yes, can't have 0 on the bottom, right? So in that case, I need to know, I need to understand that when I start over here, okay, and I end straight down, that it's going to be 270. What would happen if it ended straight up? Would I get undefined?
No. Yes.
I would get it because it would be positive 3 and 0. So it would also be undefined. So whenever you look at it like this and you see it's on the graph, I get a 0 on the bottom, I got to look to see where it's at. That is directly at 270. If it was straight up, it would be at 90. So, since it's straight down, what is my CIS going to look like here?
On DI.
So it's going to be 3 CIS of
0.
nope. What's the angle?
Negative 3, 0.
270.
270. The angle. Angle always goes next, so that's 270. Let's see my calculator. I have it in the right mode, hopefully. Dock, settings 2. Change it to polar. So if I put 0 minus 3i, did my calculator do it for me?
Yes.
Yes.
It gave it to me as a negative 90 though, right?
Yeah.
Negative 90 is going in the wrong direction. I want it to go counterclockwise. So at that same value, it's going to give me 270, which is going to be a coterminal of that, right? I would take this value and add 360. So what mode is being turned on in your calculator?
Polar.
Thank you. So if I take it back and do one of my other ones that I just did, like this one right here, I'm going to do it in degrees. What was 5 pi over 6 in degrees?
In degree.
Look at your unit circle. 5 pi over 6 is what? 150. Let's see what my calculator says about that. So 2 CIS 150. Okay. Now, my numbers are right here. Negative rad 3 plus I. Negative rad 3 plus I. So I get 2, which is the radius. This angle is abbreviating for my CIS, so my angle is 150. This does this in degrees. It won't do it in radian. Why will it not do it in radian? No. Why will radian not work? Pi. Because pi is the decimal, isn't it?
Yeah.
That's why. So always try to do this in degrees and then just convert your answer back. So this is 2 CIS 150. All right. Write each complex number in its alternate form using calculate approximation as necessary. Let's see what my calculator will do with this. Doc, 7 2. And I'm going to change it to rectangular now. Because why am I doing rectangular now? This is my polar coordinate. So I'm going to plug in 6 cosine 115, 6 cosine, open parentheses here, 115 degrees, close, plus I sine 115 degrees. There we go. So my answer is going to be in rectangular form, negative 2.54, negative 2.54 plus 5.44 I. Is that super easy now?
Yeah.
Okay, I want to see everyone plug it in right now and do it.
Got it.
Everyone should be doing it.
Plug it where?
Where do you think?
Oh
Home.
no.
You.
Uh-oh.
You look at mine?
If you're not logged in, I can't see you on here.
I'm doing.
I'm logging out.
Oh, I boy, logging out.
How about now?
I'm not using.
So, it's coming up. So, I want to see on everyone's right now, I want to see you guys actually get these answers. Like this. Okay, now, what's wrong with this answer right here?
No, I was in the middle.
Nope.
It's not rectangular.
You got to have a parentheses here and out here. Right now, you're only multiplying the cosine by the 6.
Is that mine?
Oh, you can look at mine.
Okay, so now you're still in polar. This angle right here says CIS. So you're still in polar, so change it to rectangular.
Alright.
What about me, mister?
I think I'm good.
I'm looking for you. There you are. So here's what I got right here for you. You are rectangular. Very good. Make default.
Oh my god.
Just press enter.
There you go. Now put a parentheses after the 6. Open parentheses after the 6
Over closer?
in front of cosine.
Okay.
And then close it after the sine 115. There you go.
Are you in rectangle?
All right, there you go. You got the answer. Good job.
Wait, my thing.
Okay, who's that? Who's me? Help me out, me.
Angel.
There you go. All right. So, what's wrong with yours? Yours is fine.
I'm just kidding.
Anyone else?
I can't do this. Wait, can you check mine,
Believe in yourself.
All right, who's mine? Who am I talking to?
Martha?
I'm looking for you. Did you log in?
Right there, in the middle.
Oh, there you are. I'm sorry. Okay, see this answer right here? That says that you're still in polar. Go to document. 7.2. And what mode do I need? Rectangular. Please change that. We were just on a break.
I know, but I was just standing up there.
It's your own fault. Wait till I'm done.
But I got the right answer.
I need help.
Uh-huh. Okay, let me see. All right, now I'm looking at yours. Rectangular, degree, normal, you're good. Make default.
I did.
I have yours up right now.
Oh, wait, it's not.
Okay, now see your eye? That's the wrong eye.
You gotta press the
Press pi.
Pi.
And that's the I that stands for square root of -1.
Get it right.
That's the I that you're using.
One to the right.
Where were you?
The I.
I was just pressing the letter I.
That yeah. So that fixes it. There we go.
Bada boom, bada bang.
Don't look at mine.
Is everyone else good?
Yes.
Yep.
Ashley, are we there yet?
Andres couldn't get his. He needs help.
You better stop. I got mine. Don't look at mine.
I didn't even look at mine. I knew he just did.
Do you actually hoping?
He's so done.
Is everyone else question?
Eli.
Oh.
I can't see. That's too small.
I know, I can see it from here. That's why I'm asking you guys. We good?
No.
No?
I think Andrew.
What do you got?
Sorry, no, I got the right.
Oh. You do? Okay. Because I know your phone's not out again, right?
I don't know what you're talking about.
Then go put your phone away then. Hey, go put it away. No, it's not far enough away from you. Because every time I turn around, you grab it.
Hey,
Put it further away.
I got people blowing up my phone.
Okay. I'll see what Mom has to say about that.
Hold up.
All right.
Nah, don't do that.
Okay, I can put it on speakerphone right now.
So that's an I.
Negative
Don't hype him up.
2 point what? What was it? Negative 2 point
537.
54
57.
plus
5.43.
what is it?
44.
4 I.
No.
Yeah.
Is it 4-3 and the bigger number?
Yeah. Yeah.
Okay, there we go.
Yeah.
Super easy. Hey, it doesn't mean just stand up here and man.
Everybody stand
Oh
up.
my
Okay, now
God.
earbud away too.
Not a good kid.
Okay. Now, what form is this? What form is this?
This is polar.
Hey,
Complex.
Polar.
Wait.
Clockwise.
say rectangular.
Rectangular.
This is rectangular
Why?
because it's a plus bi.
Between trigonometric and rectangular.
So, trigonometry has cosine and sine, or CIS, right?
Yeah.
Now, for this one right here, let's go ahead and, okay, let's just do it all right here. So, if I'm gonna have this, and I want to convert it to CIS,
We should need the R first.
nope. Now, let's take my values, which is 5 minus 4i. Okay, 5 minus 4i. If I'm starting in rectangular and I want polar, doc 7, 2. Change to polar, make default. Hit enter. Let me see everyone change it right now. Let me see.
Basically.
Okay.
Chris, can you please log in? Cosmo, please log in.
I'll cause your mouth. Who is Isaac? That's the real question.
All right, there we go.
Got it.
Oh, yeah. Wait, you said rectangular.
It's starting rectangular. A plus bi is rectangular. This is CIS. This is polar.
El señor. understand.
Did I get it, Bucky?
Estradas.
He's right there.
There you are. Looks fine.
Alex, what are you doing? Alex, what are you doing? I think Alex needs help. I need
Do you need help, Alex? Hey, you got it?
That's why I didn't want to open it. Huh? That's why I didn't want to open it. Why? Because I have no things for isolation.
All right. Now, listen up, please. Listen up. Okay. Everyone's at the right spot now.
Yes.
On this right here, is this going to be correct?
Yes.
No. I see you peep. No, hold on.
Nope, I don't want that negative angle.
No, positive. You're negative.
I mean, he's pretty positive, right?
Listen, I do not want the negative angle, so I need to do what?
Timed it?
Add
360.
360. I want the coterminal here. It's in the right spot. It's in quadrant 4, isn't it? It's to the right 5 and down 4. That's quadrant 4, isn't it?
Yeah.
But it's a negative, so I'm going to add 360 to that number.
It needs 3 260s. No.
That's unfair that you can do that and we can't.
You can.
Oh, minus. I knew that.
Oh, I know how to do it.
I knew that. I knew that.
So 321.3. 321.3.
321.34.
So all right, so what was my radius? What was the radius? What was the number in front of the angle?
6.4.
6 what?
6.4.
6.4? How about 2 decimals on that one?
Oh.
It's a 6.40.
40?
Yeah.
Okay. There we go.
Minus. Into.
Really, really, really easy. What is the hardest part out of all this?
Putting it in. Put it in your calculator.
Calculator, making sure it's the right mode.
Yeah, no, you got it. You gotta change it like 2 or 3 times.
It's just changing back and forth. In between every question, you look to see. This is rectangular. I'm going to put a nice little box around this. That is rectangular.
But everything is in the calculator.
So, you want it in polar with CIS, with trigonomic, so I plug it into the calculator now.
That's a 6.4. Like an infinite
Blah, 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 blah. Okay, yep, that's it. We're done with that one.
Blah, you're blah.
Doesn't that have like a infinite area?
Wait, so mister, can you come in?